Hi ladies, this is the second part of lesson 6.5 and we're again looking at graphing square root and cube root functions. So in the last lesson, or in the last video, if you remember, we graphed y equals the square root of x and y equals the cube root of x. And for any y equals a times the square root of x, we said that x had to be greater than or equal to 0, and y also had to be greater than or equal to 0. X has to be greater than or equal to 0 in your domain because you cannot take the square root of a negative number, and y has to be greater than or equal to 0 because that's if a because you can't have positive and negative outputs for a single input. If you do, then it's not a function. For the cubed root of x and the cubed root of a times x, we said that x, our domain, is all real numbers, and our range is all real numbers. Now, secondly, you should, again, recognize these forms, a times the square root of x minus h plus k. That should remind you of an absolute value function, where the vertex is h and k. Or it could remind you of a quadratic function in vertex form, where again the vertex is h as your x coordinate and k as your y coordinate. Okay, so now looking at graphing these radical functions, you're going to look at graphing the y equals a times the square root of x, or a times the cubed root of x. And think of what that a value represents. A determines whether or not you have a reflection, a vertical stretch, or a vertical shrink. So if a is negative, then you have a reflection. Over the x-axis. If the absolute value of a is greater than 1, then we have a vertical stretch. And if the absolute value of a is less than 1, we have a vertical shrink. Okay, so that's a summary from the last video. Now we're going to graph that function y equals a times the square root of x, or a times the cubed root of x, and then we're going to translate this horizontally h units and vertically k units. So again, think of your vertex form of your quadratic function or your absolute value form. H is your horizontal translation, and k is your vertical translation. Your vertical translation is up or down. Up or down. And your horizontal translation is left or right. So let's look at a couple examples. So in this next example, y equals 3 times the square root of x minus 1 plus 2. First, let's think about the domain and range. Let's think about what the graph y equals 3 times the square root of x looks like. And then we're going to translate that 1 unit h, which is 1 unit, positive 1 unit, to the right. So our h equals 1, positive 1. And our k equals positive 2. So we're going to translate the graph y equals 3 times the square root of x, 1 unit to the right, and 2 units up. So let's make a table of 3 times the square root of x, and we'll graph that. But first, let's think about what our domain is. We can't take the square root of a negative number, so our domain is our x values have to be greater than or equal to 0. And since 3 is positive 3, our range is y is greater than or equal to 0. So let's start with 0. We'll just do these 3 numbers, 0, 1, and 4. If x is 0, y is 0. If x is 1, 3 times the square root of 1 is 3. And if x is 4, 3 times the square root of 4, which is 3 times 2, is 6. So let's just graph this. 3 times the square root of x. 0, 0, 1, 3, and 4, 6. So our graph looks like this. Now we're going to translate that 1 unit to the right and 2 units up. To get 3 times the square root of x minus 1 plus k. Our graph is going to look a little bit different. We're going to start at 0 still, but we're going to translate that 1 unit to the right. So our x value becomes 1. And we're going to translate it 2 units up, so our y value becomes 2. In the coordinate 1, 3, we're going to translate that 1 unit to the right. So our x value is 2. We're adding 1 to our x. And our y value is 5. We're adding 2 units to our y value. And then lastly, 0.46 becomes 5, 8. That's 1 unit to the right. We're adding 1 to our x value, and it's 2 units up. We're adding 2 to our y value. So now if we graph this function, 3 times the square root of x minus 1 plus k, which actually our k is 2. So I should write 2 here. We have 1, 2. 2 as a coordinate. 2, 5, and 5, 8, and 8 as a coordinate. So now our graph starts here at the point 1, 2, but otherwise looks the same. So if we were to translate this graph, 1 unit to the right and 2 units up, it would look the same as our green graph. So now, since we have a set domain and range, we need to redefine our domain and range for y equals 3 times the square root of x minus 1 plus 2. Because our x cannot be 0 anymore, because if x was 0, we would take 3 times the square root of negative 1, which we can't do. So our domain is now x is greater than or equal to 1. So here's our new domain. And then our new range is y is greater than or equal to 2. Because if x is 1, which is the lowest possible domain we can have. It has to be greater than or equal to 1. So if x is 1, we have 3 times the square root of 1 minus 1, which is 0, plus 2. So our smallest y value is 2. All right, now let's look at a cubed root function. So graphing a translated cubed root function. So here we have negative 2 times the cubed root of x minus 3 minus 2. We need to do a few things first. First, let's define our domain and range of the cubed root function. And this is all real numbers. And our range is also all real numbers. We can have a positive or negative x value to give us a positive or negative real y value. Secondly, let's look at this graph. Let's look at everything we know about this graph. And let's start with our a value. Our a equals negative 2. Our h value is positive 3. And our k value is negative 2. So this a value tells us two things. First of all, it's negative. That means that it's a reflection. Over the x-axis. And by reflection, I mean reflection of the cubed root of x function. So it's negative, so it's going to be a reflection of that cubed root of x function. Secondly, because it's 2, and 2 is greater than, the absolute value of 2 is greater than or equal to 1, that means that it's going to be a vertical stretch. Now if we move on to looking at our h coordinate, our h coordinate is positive 3, so that means that the graph y equals negative 2 times the cubed root of x is going to be shifted to the right 3 units. Because h deals with our horizontal translation. And then lastly, our k is negative 2. So that means the graph y equals negative 2 times the cubed root of x is going to be shifted down. Two units. Okay, so that's really everything we know about this. We've identified our domain, we've identified our range, and we know what our graph is going to look like. So now let's actually graph negative 2 times the cubed root of x. Okay, so we need to figure out a couple points, x and y values. And again, our x can be positive or negative values, and our y can be positive or negative or 0 values. So let's look at negative 2 is kind of a hard one, so we'll have to kind of estimate what our y value is. But we'll do negative 2, negative 1, 0, 1, and 2. Just so that we can see a couple positive and a couple negative numbers. Now if you plug into your calculator the cubed root of negative 2 times negative 2, you get approximately 2.52. Negative 1, the cubed root of negative 1 is negative 1 times negative 2 is positive 2. 0, your output is 0. 1, your output is negative 2. And if you plug in positive 2 for x, you have an output of negative 2.52 approximately. Okay, so we can graph these points on our graph above. So here's our graph of y equals negative 2 times the cubed root of x. Now we have to take this and we have to shift it 3 units to the right and 2 units down. So we have y equals negative 2 times the cubed root of x minus 3 minus 2. So we're going to start with our same x value, negative 2, and we're going to move that horizontally 3 units. So negative 2 plus 3 is positive 1. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. So we're adding 3 to each x coordinate. And we're going to subtract 2 from our y coordinates. So negative 2 and 2.52 becomes 1 and 0.52. So we're subtracting 2 from each of these y coordinates. And then you can graph those points on your graph. So that is this graph, and I'm going to the right 3 units, and I'm going down 2 units. So when you graph those points, you should get something similar to that orange graph. Now, for this function, the domain and the range don't change. So the domain is all real numbers still, and range is still all real numbers. Okay, those don't change. Our arrows go. The arrows go in both directions still. It's continuing. Y continues to go positive and negative. X continues to go positive and negative. Any real number works as a solution for this graph. All right, there's a couple more problems on your note sheets. Try these ones on your own. So think of the parent graph. So how does this compare to the absolute value of x? And how does this whole thing compare to negative 1/2 times the square root of x? And same thing down here. How does this compare to the cubed root of x? And how does this whole thing compare to 3 times the cubed root of x? And that's x plus 0. So identify your A, identify your H, and identify your K. or both of these functions. So please pause the video while you work, and you can unpause for the solution. All right, so we're going to compare the graph -1/2 times the square root of x. We're going to compare that to the square root of x. And when we do that, we see that it's a reflection because our a value is negative. And we also see that it's a vertical shrink because the absolute value of a is less than 1. So because it's negative and less than 1, it's a reflection over the x-axis as well as a vertical shrink. Now if we compare this whole function, y equals -1/2 times the square root of x plus 3 plus 2, where we have our h as -3 and our k as +2. If we compare this whole thing to -1/2 times the square root of x, we see that it's a horizontal shift -3 units, which means 3 units to the left, and a vertical shift up 2 units. So here's our original graph of y equals -1/2 times the square root of x. It goes to the left 3 units, and it goes up 2 units. And you can actually plot out coordinates for that new graph by adding or subtracting 3 units from your x value, so 0 becomes -3, and adding 2 units to your y value, so 0 becomes +2. Now when we set the domain for our y equals -1/2 times the square root of x, we have x has to be greater than or equal to 0, but because a is negative, our y is going to be less than or equal to 0. And when we set our new domain, our x is going to be greater than or equal to -3, and our y is going to be less than or equal to 2. Now let's do the same thing with the cubic function. So here we have y equals 3 times the cubed root of x plus 2, and we're going to compare it. We're going to compare 3 times the cubed root of x to the cubed root of x parent function, and we can see that it's a vertical stretch, a factor of 3. And now if we compare 3 times the cubed root of x to this new function that we have, 3 times the cubed root of x plus 2, we can see that it's going to be a vertical shift up 2 units. So this red graph is that 3 times the cubed root of x, and the purple graph is this whole thing, 3 times the cubed root of x plus 2. You can identify your a, your h, and your k. In this case, since we just have the square root or the cubed root of x, our h is 0. And our domain and range for this 3 times the cubed root of x is all real numbers, and our domain and range for the whole function is still all real numbers. It doesn't change. It continues to go on forever in the positive x and positive y direction, as well as the negative x and the negative y direction. So we can see that this 3 times the cubed root of x plus 2, that function is just a vertical shift up 2 units. Okay, so we don't have any horizontal shift because we have h is 0, but we do still have a vertical shift up 2 units because of this k value of 2. So please jot down any questions you have, and we can go over them next time I see you. Thank you.